What I'm going to do today is very important. It's important from the point of view of knowing the Keynesian model. I gave you a very simple version of the Keynesian cross model where there was no government, but Keynes's model and Keynesian policies cannot be discussed without having government in the model. Because what Keynes said basically is that there are times in the economy, maybe in the short run or medium run, when the economy is so down that you need active government intervention to pull the economy out. Like somebody is ill and you need a doctor, a specialist, to suggest medicine and other things to bring him out of it. So the economy requires a doctor, and an important contribution towards that end comes from the government. Private sector does contribute, but government. So without talking about government, no Keynesian model is complete. So now I think I called that case A. Did I call that case A without government? So I'm going to do the case B today, which is more of a Keynesian model. But case A had some important insights. Multiplier, the goods market clearing condition turned out to be the same as the classical model. Savings is equal to investment. We had some important results there. But case B is what we are going to begin. Case B is with government. So the thing is, as soon as you have government, how does G enters? Well, the total output of the economy would have to be thought of Y as now private goods and government goods, which are also known as public goods. So government goods, public goods, and private goods together make up Y. But on the demand side, right-hand side of that goods market clearing condition, you now have explicitly government variables. Earlier, if you look up case A, it was only private variables, consumption expenditure and investment expenditure, two items. But now we would have government. Now when you have government, there are two major changes that will take place in that equation. Not only that government expenditure will be added as part of the demand, because government spending means demanding some services are supplied and required in the economy. That kind of an assumption is there, G, government expenditures. But there is one more thing that will happen. With the government, you just don't have government expenditures. Government just doesn't spend money on roads and other infrastructure items, services like the defense services, police, the MPs, MLAs, the bureaucrats. But in order to spend that money, government requires money, income. And therefore, you will have tax. And in this model, it won't be sales tax, indirect taxes. In this model, indirect taxes are usually considered in microeconomic models, where a company is producing something and a tax is imposed on it when it goes to sell it. But here in macro models, what we have is, we have income taxes. So direct taxes you can call. So if you recall, in national income accounting methods, I said there are some variables that you can obtain from national income. And I named them: personal income, personal disposable income. Then at the end I said there's one variable which is closest to the macro model, and that is disposable income. So what I would require now is the disposable income coming into the picture. So now if you have disposable income, common sense would say the following things, that you are essentially therefore talking about that at an individual level and also at the macro level, when people earn something, they don't necessarily use that money. They cannot use that money because first they will have to pay the taxes. And the taxes that I'm talking about are direct taxes, property taxes, estate duties, income taxes for various types. Companies pay one type of income taxes. Personal income tax is there at an individual level, like the one I pay or you would pay tomorrow when you have a job. So one thing is, consumption will therefore depend upon the income net of taxes. After the taxes have been deducted, whatever income remains with you, now you can spend. So essentially we will get into the concept of disposable income. But disposable income is just not national income minus direct taxes. If you open up disposable income, you realize that there are an important variable which constitute income or disposable income, and it was there since personal income also, is that government transfer payments. There is a large section of the society, depending upon the age group in the society. I've been told that in countries like Germany and other places in Europe, there is increasingly larger share of the retired people, because the people who were born at a particular time, and after that there was birth control probably, so the growth rate or birth rate was down. So now the countries are reaching a stage where a lot more people are retiring. Now in that country, does it mean that the retired people don't eat anymore, don't spend anymore? Of course not. So they get a lot of transfer payments from government to survive. So in order to construct the disposable income variable, not only you need taxes, direct taxes, what I mean, to be deducted, but also we need the transfer payments to be added, so that you have a proper estimate of disposable income out of which the country would be spending or consuming. Having said that, therefore, case B I begin, case A I discussed without government, case B I begin in the following manner. Let's see whether you feel comfortable or not. Anyway, so case B. Keynesian cross model with government. The two changes that need to come, two changes have to be brought in. One, on the demand side, you will have C plus I, which was autonomous investment. I retain autonomous investment, C plus I, plus G naught, which is government expenditures. This is the first change. Next, C will be a function of, now not Y, but C would be a function of, there will be an autonomous consumption, plus C would be a function of disposable income, where YD is disposable income. YD is disposable income, and YD is simply Y minus taxes, call that capital T, plus transfer payments, I call that TF. So T are taxes, and they are direct taxes, and this is transfer payments. Direct taxes, and these are transfer payments. Two changes coming. C is not linearly related to income. It's now linearly related to disposable income, because the disposable income is the one out of which you spend or save. You don't spend out of income anymore. You have to pay the obligations, meet the obligations, you have to pay the taxes to the government. And then Transfer payments constitute part of the disposable income. Retired people spend out of transfer payments. The funny thing is that I don't want to model it here. Once upon a time I asked some retired people about their pension checks. Pension check amounts also, after a point, are taxed. They are also taxed, but I don't want to model it here. In India, pension checks of a retired person, after a point, after a particular threshold level, they are taxed. Okay. But I don't want to. I'm keeping it without taxes plus transfer payments. Now the question is T. In macro models, taxes, direct taxes are typically modeled in these. There are two versions that are available. Two versions of T. One is lump sum tax. That is a fixed amount government collects from everybody and in the economy, which doesn't change with the income level. Fixed amount you have to pay. Lump sum tax, in which case T is equal to T naught. And another system that I've seen are the proportional taxes. Proportional tax. In that case, T is equal to small ty, where small t lies between 0 and 1, and therefore taxes are proportional to income. This is another typical assumption in macro models that I've seen. Taxes are modeled either of the two ways. Lump sum tax, so it's like an autonomous variable, fixed. It doesn't change with income level. Or you can have proportional system. T is equal to small ty. All right? Okay. Now, having said that, therefore, what I have is the following thing. What shall we do? Which one would you like? Let's use the proportional system. Lump sum tax you can work out yourself. So let's use the proportional system. Let's use this one. This one. Therefore, the goods market clearing condition becomes y, which is equal to d. Therefore, y is equal to a naught plus c into y minus t plus tf, and where a naught is equal to c naught plus I naught plus g naught. Now let's assume government expenditures also to be autonomous, fixed. It doesn't depend upon the income of the country. It decides what it wants to spend. And government is also, think of something like the moon with respect to Earth. What it does, the moon matters to Earth, but we don't control the moon. Moon is on its own. The sun on its own. We don't control it. But what the sun does matters to us. Or what happens to the sun matters to us. That kind of a thing, all right? So government expenditure and autonomous variables, A naught are autonomous variables, C naught plus I naught plus G naught. And here we have a complication now. C is equal to y minus t plus tf. Or you can see what you will get. You will get y is equal to A naught plus C into y minus ty plus tf. So you will have A naught plus C into 1 minus ty plus CTF. This kind of a relationship you will have now. All right? So y is equal to A naught plus C into 1 minus ty plus CTF. Is that clear? Okay. Now, before we move farther, if you remember, last time without government, I worked through the equilibrium condition, this one, and came to the relationship S is equal to I. I want to obtain a similar relationship. So before I do that algebra, just recall that, just remember one of the things. Now, what will be the income identity? The new income identity, what will it be? The new income identity. What will be the new income identity? Very good. It will be now YD is equal to C plus S, because you consume out of disposable income, so you save out of disposable income, and not Y is equal to C plus S. This is very important, not Y is equal to C plus S. So now YD is equal to C plus S, you can see therefore S is equal to YD minus C, all right, and therefore YD is equal to Y minus TY then plus TF minus C, all right. So this is equal to Y minus TY plus TF, and C is how much? Where is C? That one is C there. C is equal to minus C naught and minus C into YD, which is Y minus T, that means small ty plus TF. All right. Now you can club terms here. Y and minus CY can be together. It will be 1 minus C into Y. This term and this term. Then minus TY minus minus plus CTY. All right. So what will it be? It will be minus TY and minus minus plus CTY. So you have to do, if you take if you have to do minus T, am I correct? Minus T into 1 minus C Y. Am I correct? Am I correct here? 1 minus CY, then minus TY and minus C into minus TY plus CTY. If you take a minus out, then it will be T factored out. It will be 1 here and it will be minus C there. Next you have TF and TF, and here you have minus CTF. So it will be plus 1 minus C TF, and remember, do not forget, this one is done, do not forget this term, so that should be added, minus C naught. All right. Now therefore S is equal to 1 minus C naught. S is equal to minus C naught. First I write, then 1 minus C into Y. 1 minus C is small s. Remember, marginal propensity to consume plus marginal propensity to save is equal to 1. So 1 minus C is small s plus small s into Y minus T into small s Y minus T into small s Y plus small s TF, that's what you have. All right. So this is equal to S naught plus, you factor out small s, you have y minus ty plus tf, or is equal to S naught plus small s y minus capital T plus capital TF. So this is the savings function. Therefore, you have this as the savings function. S naught, and S naught is equal to, as you know, S naught is equal to minus C naught, and small s is equal to 1 minus small c. Clear or not? All right, so that's the savings function. Now what I need to do is to use this particular equilibrium condition, which is called the goods market clearing condition, and give it a parallel interpretation similar to S is equal to I. And let's see what happens if I try to do that. All right. Now, this condition has come from here. This condition has come from here. So what you require, recall the clearing condition. And what you have essentially is y is equal to c plus I naught plus g naught. This is what you have. All right? Okay? Now, y minus c is therefore I naught plus g naught. Y minus c is minus c naught minus small c into y minus t plus tf is equal to I naught plus g naught. All right? Therefore, minus c naught y and this plus 1 minus c into y, this term and this term goes. Minus c into minus t is plus ct, which is plus ct, minus minus is minus ctf, is equal to I naught plus g naught. Minus c naught is S naught plus 1 minus c is small sy plus c is 1 minus small s into t minus c is 1 minus small s into tf is equal to I naught plus g naught. Any problem? All right. Now this will be equal to S naught plus small s y minus small s t minus minus plus small s tf. This term will come, and it will, what will be remained here is that 1 into t is plus t, and minus 1 minus tf is equal to I naught plus g naught. Clear? Therefore, S naught plus, what is this? S into y minus t plus tf is disposable income. So this is entirely the savings function. S naught plus small s into disposable income is a savings function, plus t minus tf is equal to I naught plus g naught. So what you have is a very important result. This part is essentially savings. This is plus t minus tf, these two coming from here. That equals to I naught plus g naught. This is a very important result. This result is very important. S plus t minus tf is equal to I naught plus g naught. It's a very different one compared to what you have seen earlier. It's a very different one. S plus T minus TF is equal to I naught plus G naught. No longer S is equal to I. No longer S is equal to I, which you had in the classical model, which you also had in the simple Keynesian cross model without government in the previous class. You don't have it anymore. This is the one you have. Now, it looks very naive. It looks like a very simple model we have, and from there we have an algebraic relationship. But these relationships to me provide quite a bit of insight into the working of the country or the economy. Look, here, I naught is a private sector variable, S is a private sector variable, and these are government variables. So now if I want to rewrite this equation in terms of government's budget, what do I have? It's very interesting what you have. You bring I naught on this side, so you have S minus I naught, and here you have G naught plus TF minus T. This is what you have. Okay? What is it saying? This is government's total expenditure. The amount I spend on goods and services plus the money that I transfer to the private economy for people to live, which I have from them from the past, but in the current period I'm giving that out to them. Total government expenditure. Minus taxes are the direct taxes that I collect as a revenue. Suppose I ignore indirect taxes, which is not there in this model. The taxes that we pay indirectly when we buy a good and goes to the government. If we look at the direct tax revenues, and if we think about this as a government budget deficit or surplus, whichever way we want to interpret, this variable can be interpreted as something like budget. Some people call it budget surplus. Actually, it should be written the other way around, budget surplus. Surplus, expenditure minus income I have done. It will be a negative of that. But anyway, suppose this budget surplus is positive. Does it mean really? Positive means it's actually, this is like a budget negative of budget surplus. This is the inverse of the budget surplus. I should put it this way. This is the inverse of budget surplus. You can call that budget deficit. This is the inverse of budget surplus. Like say you can call that budget deficit. All right? Inverse of that will be budget deficit. That means if this is a positive number, there's a positive budget deficit. G plus T is greater than T. That means the government is spending more than direct taxes it is collecting. All right? So budget deficit positive essentially implies that, say, budget deficit, if this one is positive, then it implies that G plus TF is greater than T. Budget deficit is equal to 0 implies G plus T is equal to T. And budget deficit is negative implies G plus T is less than T. That means negative budget deficit means budget surplus. Government is spending less, so it has a surplus budget. All right? You agree with me or not? Now look at this. This is simple, of course, budget deficit or budget surplus. Look at this. If the private sector saves more than private investment, if this side is positive, the right-hand side must be positive too. Otherwise, how will that equation balance? If left-hand side has plus 4 as a number, that equation means right-hand side also has a plus 4 number. Which means if the private economy saves more than what private investment demand is, government has the liberty to spend more than what it collects as direct tax revenue. That means what it is doing is the following. One can argue that if other way around, if government spends more than what it collects as tax revenue, if the right-hand side is positive, which means the private investment must be less than private savings, because some of the savings are now channeled through banks maybe or non-banks into the hands of the government. Because how is government financing its extra expenditure? In this simple model, it's financing the extra expenditure. G plus TF is greater than T, means it is not collecting enough direct tax revenues. So automatically it means, according to this equation, is that the left-hand side is also positive, which means private savings is more than private investment. So where is the private savings going? It is not going to investment. Private investment is going to the hands of the government. On the other hand, if here you have a surplus, a negative number, it should be a negative number here. Unfortunately, surplus is being shown in this equation as a negative number. If it is a negative number here, then it should be a negative number, which means that if private savings is less than private investment, government is spending less than its tax revenue. That means part of the tax revenue is therefore getting channeled through some route into the private investment. Through banks, through intermediaries, God knows what. All right? So now you would understand what the classical position is, why classicists dislike this kind of a model, Keynesian model, where the role of government is so important. Because classical macroeconomists say that if government spends, it chokes private investment. What it basically means is, if government spends, all right, if government spends, then it eats up into the direct tax revenue. Otherwise, it could have gone to private investment. And if government has a budget deficit, it's terrible news. Not only it is not helping the private sector, it's eating up private savings. If it is positive, it has to be positive, which means savings is more than private investment. So extra savings are not available to private investment. They are channeled through banks, etc., non-banks, into government. That's why classical macroeconomists take a political position also. This is economics which is trying to explain that, is that a government and too much of government eats into the private system, doesn't allow the private sector to go. Whereas in a capitalist system, you say what? It is the private sector which thrives, is the free enterprise, individual interests which are when pursued, you have the best possible result, not state control. That's where the capitalists and the communists would fight. But in a capitalist system, you do have mixed systems where private sector and public sector live side by side. And what this equation is already telling you, where too much of government activity, spending, etc., will eat into private savings and private investment. Look at this equation. Now go back and study this, what I've said. Pay attention to what I've said by looking at this equation. I hope the algebra is correct. All right, check the algebra also. So this is what I wanted to do. There are many important things now coming up about the macroeconomy. And this is where classical macroeconomists would all the time fight with the Keynesians, because the Keynesians would say government's role is essential in some time periods, but the classical macroeconomists dislike the presence of government and too much of government. All right. Now comes the diagrammatic part, and life won't be too much of a fun. Anyway, these equations we keep, and let's see whether we can have some diagrams. So S plus T minus TF is equal to I naught plus G naught should be coming out in the diagram. Let's see whether it comes or not. I would still prefer to draw the diagram, consumption function and savings functions, against y variable and not yd. I would still prefer that. The older axis that I had in the previous class, what I had. I still would prefer this. Y and D, and I will tell you what I have here a little bit later. I'm going to tell you what I have here. First of all, note the following things. The consumption function we need to draw. What is the consumption function now? Recall the my goodness. The consumption function. Okay. What is the consumption function? C is equal to C naught plus small c into 1 minus t y plus c tf. Am I correct or not? Am I correct or not? If you don't understand this, let me know. Is this the consumption function now? Consumption is a function of disposable income. Am I correct? So let's draw this. You can see there are two autonomous parts. TF is also a constant from transfer payables. You can put a naught there if you wish. Then C naught plus CT naught F, this can come here. All right? So you will have here C naught plus small c TF, and you have C into 1 minus t as the slope along y line. What is the slope? dc dy, C into 1 minus t. That's the slope, not C. Slope is C into 1 minus t now against y axis. So this line would be something like this. C is equal to C naught plus small c into 1 minus ty plus CTF. This is the consumption line. Now what is the equilibrium condition saying? Equilibrium condition is saying that S plus T minus TF should be equal to I naught plus G naught. Let's add the aggregate demands here. D is measured. So D is what? C plus I plus G. Total demand is what? C plus I plus G. So add I plus G, which is I naught plus G naught to that, and then you have a shift to a line like this where you have now I naught plus G naught plus C naught plus small c TF. You can put a naught if you wish. So that's what you will have. This is what you will have. This is the aggregate demand line, which is C plus I naught plus G naught. That's the aggregate demand line. Am I okay with this? All right? Am I okay with this with you? Are you okay with this? Am I okay means are you okay with what I'm saying? All right? Okay, now we need the 45-degree line, which is like something like this, 45-degree line. And this is the equilibrium point. Because you recall D is equal to Y, and along the 45-degree line, D is always equal to Y. So wherever that aggregate demand intersects that 45-degree line, you have the equilibrium point. The question is, what will be the diagram here? The diagram here would logically say that I naught plus G naught, that is this gap, I naught plus G naught, this one, should match an S plus T minus TF. The question is, how do I draw the S plus T minus TF? S plus T minus TF, that should be S plus T minus TF. So ideally, this diagram here on the y-axis, you should have, in this axis, you should have S plus T minus TF. But the question is, we don't know the S plus T minus TF line. So we need to work that out, S plus T minus TF line. So let's work that out. S plus T minus TF. What does it mean? It means minus C naught, which is S naught, plus small s into yd, which is y minus t plus tf. which is equal to minus C naught plus T minus Ty. So 1 minus S into 1 minus Ty plus STF. And you will have plus T minus TF. And it will be plus T minus TF. Do not forget this. So this is equal to essentially minus C naught, which is S naught, plus S into 1 minus T Y, plus you have STF and minus TF. What will it become? STF and minus TF. So minus 1 minus S, it will be CTF, minus CTF, right? It is a minus 1 here, and you factor that minus 1 TF out. Minus TF is 1 minus S, 1 minus S is C. So it will be minus C TF, and what will plus T represent? What will plus T? It is plus Ty. All right? So we have more algebra now coming. Is equal to minus C naught plus Sy and minus STY, and here you have plus T, plus Ty. So minus STY plus Ty. This one minus CTF. Am I correct? C naught plus SY minus STY, and then I'm bringing Ty, which is small ty, minus CTF. Now, what will it be if you take Ty factored out? 1 minus S. All right. So it will be equal to minus C naught plus Sy plus C into T CTY minus CTF. Minus C naught plus Sy plus CTY minus C into TF. So what I have, therefore, the slope of S plus T minus TF line is, which will be equal to ds plus T minus TF dy will be equal to S plus CT. That's the slope. And TF naught, I should put a naught here. I'm forgetting to put a naught. These are constant terms. So if you put a naught there, this and this is the intercept of that line, which is similar. You look at the consumption function, C naught plus CT F naught. The opposite of this will be minus C naught minus CT F naught, which you have here. Minus C naught minus CT F naught. Just the opposite of it. Did you see that? All right. So here, this amount I should translate here. That's the place where you have minus C naught plus C TF naught. Not plus. Is it plus CTF naught or minus CTF naught? Why is it minus? There is an error somewhere. Minus C naught plus S into Y. So STF naught minus TF naught is minus 1 minus S. Yeah, it will be minus. It's the opposite of it, nah? It will be minus. Absolutely correct. Minus CF naught. And now the question is this S plus T minus TF should show at this point the same amount of height. This is the height that it should have. This is the height that it should have. So it should have this kind of a height here, which is this one. This is the height. And this line, this savings line, will go through this from here and here, more or less all right. This is the S plus T minus TF line, whose slope is small s plus t. The slope is this angle alpha, this tan alpha is not s but s plus ct as the slope. Earlier savings function in the Keynesian model with no t, it was s, t is 0, it will become s, small s, all right? So it will become tan alpha is equal to s plus t minus, if t is 0, it will be only s. The earlier line was s only. Now s plus t minus tf will have a different slope, which is steeper than the previous line. Previous line was only savings, but now a plus term is added, a positive term. The positive term is plus c into t, however small it may be. Taxes and direct taxes average rate is say 20%, 0.2, and savings marginal producer consumer is 0.7. So 0.7 into 0.2, how much is it? 0.14, which is not very large amount, but it's still added. So the savings function line, if you go back to the earlier diagram, which I drew on Friday, it was only S line. Now S plus T minus TF will be small s plus small ct. That's the line, and that's alpha, the slope of the line, all right? And these are the heights. You can name the heights. Call this ना एक नाम दे दो EF, and you can call this also EF if you wish. So there is an income level, some Y star or maybe YE, equilibrium income level, where you have equilibrium income level where you have S plus T minus TF is equal to I naught plus G naught, the goods market clearing condition. The difficulty is to get this S plus T minus TF line slope, then you can draw it and the intercepts. And the intercepts are consistent with the earlier one. In the previous diagram, it was C naught here only, no TF term, and it was minus C naught here. But now we have C naught plus small c TF, we will have minus C naught minus CTF, just the inverse of it, all right? The minus number. So this is what you have as the new diagram, Keynesian cross model diagram. Before I proceed further, there was a concept of break-even income. I told you that the economy reaches break-even income when income matches consumption exactly and savings become zero, all right? Now note here that where is the break-even income, because we have disposable income now, and consumption and savings are function of disposable income. So where is the break-even income coming? So we can investigate that also and find out what break-even income would mean. In this diagram, I can see S plus T minus TF is equal to 0, and we don't know what that point corresponds to. All right? We really don't know what that point corresponds to. Now we know one thing, that YD, we know YD is equal to Y, YD is equal to consumption plus savings. We know that. All right? So it means Y minus T plus TF is equal to consumption plus savings. So So if break-even income, if YB implies that income in the economy is equal to consumption, all right, then it also implies that S plus T minus TF naught is equal to 0. So that's the point where you have break-even income. S plus T minus TF is equal to 0. That's where Y is equal to C. So that point should correspond to Y is equal to C point. My diagram is not great, but I hope you have understood. Diagram is not great, but you have understood what I'm trying to say, that this should be the break-even point. But remember, in the break-even point, you don't have S is equal to 0 anymore. In the earlier diagram without government, it was S is equal to 0. But you now have S plus T minus TF line is equal to 0. Value is 0. It crosses the x-axis. In the previous diagram, it was the S line which crossed the x-axis. And YB is the break-even income when C is equal to Y. You see that? This was the case earlier also. C was equal to Y. But here we had S is equal to 0 because we had only S line. But now we have S plus T minus TF. If you draw the S line, what it will be? The S line will be here only minus C naught. So one negative term gone. So the intercept will be somewhere here above this. And it has a slope only small s, which is less than this. So that line, S line, will be somewhat flattered, like it will go like this. It will be flattered. This will be the S line. And here you will have only minus C naught. And the slope of the S line is small s, so it's flatter. That will be the S line. Isn't that true? And where S intersects that x-axis will be to the right of the break-even point. Break-even point I have mentioned like this. But I don't know. I mean, I hope this is correct. Sometimes I don't know because sometimes textbooks contradict each other. One author says this, another. Somebody might say break-even point is where savings is 0. तब तो हो गया गड़बड़. क्योंकि savings 0 हो, तो YD will be equal to C. That means YD is equal to C. ये line में होता है when Y minus T plus TF not, वो line तो है ही नहीं इधर. तब क्या होगा? तो मुश्किल हो गया. तब तो काफ़ी मुश्किल हो गया. अच्छा. So up to this point we go today. Is that all right? Okay. Now, having done this, let's take the expenditure multiplier. What will be the expenditure multiplier here? Let's check out the expenditure multiplier. Let's check out the expenditure multiplier. What was the goods market clearing condition? Y is equal to A naught plus C into 1 minus Ty, and A naught, you can put all terms now, autonomous terms, even transfer payments, put them there, all autonomous terms. So what will be the expenditure multiplier? Expenditure multiplier in very simple terms is dy d, say any term here, say g, dy dg. So you delta, you do that, and it will be 1 over 1 minus c into 1 minus t. Check that out. Dy dg, if you do, where you allow one of the variables g to change, then it will be dy is equal to dg plus c into 1 minus t dy. Dy clubbed together will be 1 minus c into 1 minus t, and it will be dg. So dy over dg is 1 over 1 minus c into 1 minus t. ठीक है? Very good. All right, with all of you? All of you, right? So that's the expenditure multiplier. Now, if you look at this expenditure multiplier, if this one, now if this multiplier is compared to the earlier multiplier, if this multiplier is compared to the earlier multiplier, what will it be? It has shrunk, it has, the effectiveness has gone down, or the effectiveness has gone up. Earlier it was 1 over 1 minus c, but 1 minus c is multiplied by a fraction 1 minus t. T is say 20%. So it will be only say 80% of c is effective here. So 1 minus c, that is fallen. So the denominator value has gone up, because 1 minus a lower number is a bigger number. So what has happened is the effectiveness of expenditure multiplier has reduced. So effectiveness of the expenditure multiplier has reduced. The multiplier has become weaker. Why is it so? Because every time an additional income individuals earn in the multiplier process, multi-stage multiplier process, I had a geometric series in the previous class. Initially there is a delta G increase in expenditure and output and income. The following period C of that is spent. Every time people want to spend C of it, they realize they cannot spend C of it. They have to spend C into 1 minus T of it. Because T of it is taxed, so 1 minus T remains with them. Every rupee they earn, T amount is taxed, say 20 paisa. So 1 minus T, which is 80 paisa, remains with them. And out of 80 paisa they can now spend. So there is a leakage in the system. The leakage is in the form of, like, you have a bathtub or a tumbler. There's a small leak, so water is flowing out a little bit. So every time the economy earns some extra income, they cannot spend that out of it. They have to first pay the taxes, then they get the disposable income with them, and out of the disposable income they can now spend. Huge problem. So the effectiveness of multiplier goes down, because if they spend less, lesser amount of goods will be demanded, so lesser amount of goods will be produced in the next period, additional goods. So in the following period again, even lesser amount of goods will be produced, because again whatever income is earned, something is taxed out of it, and net of taxes remain with the consumers who spend. So effectively what is happening is the expenditure multiplier effectiveness has gone down. It's not that effective. So if government spends 100 crores to boost the economy earlier, say the multiplier, let me give you an example. Suppose point C value, let's take a number. That will be better. Suppose C is 0.7, so 70% of the income people consume in India, average. Suppose the tax rate, direct taxes is 0.2. So construct the two multipliers, say K and K prime. K is 1 over 1 minus C, and this is 1 over 1 minus C into 1 minus T. Once you construct the multiplier, you realize that 100 crores, if government spends under this condition, the increase in output will be much larger than 100 crores when the multiplier is this. You can find out the number, these two multipliers. Find out the two multiplier numbers. One is K, one is say K prime, the new one. So what are the multipliers? 1 over 1 minus C is 1 over 0.8, which is 2 point something, 3 point something, 3.33. All right. So this is 3.33, and how much is that? With 20% tax, direct taxes? 2.27. 2.27. That's what you said? So it is 2.27. Can you believe how much it has shrunk? So every time 100 crores and any one extra rupee spent, the additional income will not increase that much. So the effectiveness of the multiplier has gone down. And this is because of a leakage in the system, because government, every time there is an income earned, government says, aha, pehle humko to de do mera share. Uske baad jao kharcha karo. So every turn, every stage, हमको तो दे दो. उसीलिए आदमी बहुत चालू है, टैक्स देते नहीं हैं. Government को देना नहीं पड़ेगा. So in India, effectively, with not paying the taxes, the expenditure multiplier should be large. So have you understood this, what I said? The expenditure multiplier. So the expenditure multiplier essentially goes down. Okay? All right. Now if I ask you, work out the transfer payments multiplier or autonomous consumption expenditure multiplier, autonomous investment multiplier, you would be able to do that? You know the method now, very simple. In fact, government expenditure multiplier, autonomous consumption expenditure multiplier, autonomous private investment multiplier, all will be the same because they are under A0. Except transfer payments multiplier, there is a small c term. So it will be a small c at the top, at the head. All right? There will be a small c. Okay. Now, a few more things I have to tell you, and I don't want to really rush through it, if you are okay with this. Up to this point, are you okay with government? Here you have a tax, and often in a country, particularly before budget, you would listen here, that the private companies, those clubs, FICCI, and there's a tax rate here. So what happens typically, the finance minister gets request from the individuals, consumers, from the companies, sir, please lower the tax rate. Often that's the case. All right. So it's a common macroeconomic issue which every year during budget finance minister has to face. Company का club जो है FICCI और CII, Confederation of Indian Industry के ASSOCHAM चले आते हैं बड़ा बाबू लोग और बड़ा बाबू के पास फाइनेंस मिनिस्टर को through TV, householders, common man on the street requests, Pranab Babu, please lower the personal income tax, please get rid of the education cess, there's an extra tax we pay. On the tax revenue, some 10% of that money we pay towards education expenses, which government collects and spends on underprivileged education systems, whatever. They have various programs running. So there's an education cess, sir, please remove that, lower the income tax. This kind of statements we often hear. All right. So we would like to know that we are macroeconomic students, that expenditure multipliers we worked out, is there a tax multiplier? We would like to know that. So the next thing I would like to do is to work out the tax multiplier. But that one I won't use calculus to work it out because we don't get exactly the correct expression. So let's talk about the tax rate multiplier. Now the tax rate multiplier. The tax rate multiplier, let's assume initial equilibrium in the economy. Y naught is equal to C naught plus I naught plus G naught plus CTF naught plus C into 1 minus the initial tax rate T naught into Y naught. Initial equilibrium values, all right? So if you arrange terms here, what you will get is Y naught is equal to some A naught values in the numerator divided by 1 minus C into 1 minus t naught. Next, suppose the tax rate changes, whatever, it may have fallen or gone up. The tax rate changes to T1. Then you have the new equilibrium values after the change. New equilibrium values, y1 is equal to a naught into 1 minus c into 1 minus t1. Okay? All right? Okay. Now, all we require is, therefore, the thing that I would require is divide y1, call this 1, expression 1, and call this expression 2. So divide 2 by 1, divide 2 by 1, what you have is, divide 2 by 1, y1 over y0, क्या होगा? So y1 will be a naught over 1 minus c, 1 minus t. So नीचे में आएगा 1 minus c into 1 minus t1, और ऊपर में आएगा 1 minus c into 1 minus t naught, and a naught तो कैंसिल कर जाएगा. ठीक है? Now I subtract 1 from this. So what you basically have is y1 over y0 minus 1 is equal to 1 minus c into 1 minus t naught, 1 minus c into 1 minus t1 minus 1. So it will become y1 minus y0 over y0. y1 minus y0 over y0 is equal to 1 minus c into 1 minus t naught minus 1 plus c into 1 minus t1 divided by 1 minus c into 1 minus t1. Am I correct or not? ठीक है? So what you have essentially is delta y, इधर में y1 minus y0 over y0, and in the numerator you have 1 and 1 cancels out, minus c plus c cancels out, plus ct naught, and either में minus ct1. So you have c minus t1 minus t naught. Am I correct? 1 minus c, 1 minus t1. Am I correct here? Please find out. So one more step required. I'm going to use a colored chalk, and let's see if I have emphasized. So delta y and t1 minus t naught is delta t. So you have delta y over y is equal to minus c delta t divided by 1 minus c into 1 minus t1. So you have delta y over delta t is equal to c, this one is y0, no? C y0 over 1 minus c into 1 minus t1. Now I've done it in discrete terms, the tax rate, because if you use calculus you won't get y0 here and t1 there. You use calculus, you won't get this result. dy dt, if you want to find out, you won't get that y0 in the numerator and t1 in the denominator. But in the textbook, what you will find is this expression. And then you would wonder, sir, how did the textbook writer get this expression? So I took you to these steps. All right, this is a few steps I've taken you to get this multiplier. In textbook, what they would write, in simple, what they would write, dy dt is equal to minus cy naught over 1 minus c into 1 minus t1. Simply they would write that. They won't derive that for you. Now that's a huge problem. So you know how I got this expression? One day I got fed up. I asked a student in the class, early, many years back, 15 years back maybe. I said, please go back today and do one job for me. Find out how do the textbook writers get this expression. Then he went through this discrete simple step, their method. This method, the student showed it to me. One of your seniors, many years senior. They helped me in many ways earlier, in the very early days. I said, just show that to me. How do they get that? Because I really couldn't think how they're getting this. Because they're writing calculus notation and get it. I'm not getting it. So then I found what they're doing. They're doing a discrete calculation like this, step by step, and then simply replacing delta y delta t by dy dt. Bahut chalu hai to. And I'm trying to get this using dy dt, which wasn't coming. You can try that out yourself today. So it has a y naught term in the numerator, and it has a t1 new tax rate in the denominator. Very important. This is a very important multiplier. It confuses people. Textbooks often do not have derivations. So now we have the derivation here. All right? Okay. So you take the delta version or whatever. So it will be delta y into 1 minus c into 1 minus t1 minus c y naught delta t. So I can write it as delta y is equal to minus c y naught delta t, then plus c into 1 minus t1 delta y. Delta y is equal to minus c y naught delta t. Delta y is equal to minus c y naught delta t plus c into 1 minus t1 delta y. So what has happened? Suppose government gets a tax reduction from 20% to 15%. Immediately people have to pay lower taxes. They have more disposable income. So they will spend out of the original income, whatever they had, they will spend c times y into the delta t as an extra that they can spend. The tax reduction has released some money into their pocket. Earlier they were paying it to the government, but the delta t, the tax reduction, has now given them an extra money which they're not paying to the government. So out of the old income, that what they would spend, so that would create a total demand and income again in the economy to the extent of delta y. But delta y, when taxes are cut, also has another part. This is the direct impact. What is the next impact? The next impact, it is saying c into 1 minus t1 into delta y. When the income changes, all right, with a lower tax rate, they can, for every increase in income through the multiplier process, they would be spending a larger amount of it, and therefore placing a larger amount of demand on for the goods in the economy. Because at every stage income changes, they are now paying a lower tax, so they have more income in their pocket. That's like the first stage, and that's the second, third, fourth stage, and all the stages where they will have to spend. They can spend a larger amount because 1 minus t1 is larger now, because t1 is smaller than earlier tax. So 1 minus t1 is larger. So c into 1 minus t1 times whatever increase in income that will take place through the multiplier process in the economy. You know, every time when you spend, they earn some income and you spend again, people go home with that increased income, they spend out of it, again some demands demand for goods are placed in the economy, generate another round of income, out of which you spend again. So this is what you will have. So there are direct and an indirect effect when a tax cut. As soon as the taxes are cut, whatever income I'm getting from IIT, I go home with a larger amount of money because I'm paying lower taxes, so I spend extra. As soon as extra is spent, an extra demand for goods are created. Companies would produce an extra amount of goods economy-wide. Imagine how big that is. Just not one person, millions of people, crores of people, all right? Generates extra income, out of which again people would spend, and generate again extra demand, again people would spend. The multiplier process will go on. So those are the induced effects. So these are the direct effect. This is the direct effect of a tax cut, of a tax change, tax rate change. And these are the indirect effect or induced effect, indirect or induced effects of the increased income or of the changed income, I should say, changed income due to tax rate change. How do you clear? Take a direct and indirect effect when taxes are cut. So the total effect on income, both ways. If taxes are cut, look, there's a minus sign. There's a minus sign. So if taxes are cut, what will be delta T value? From 20% to 15%, it will be a minus value. So minus into minus, plus ho jayega. So that minus cancels out or becomes plus, whatever you say. So delta y is therefore positive because cy naught is a positive term. 1 minus c into 1 minus t1 is a positive term. So there is a tax multiplier. But if taxes are increased, delta t is positive, the ratio should be negative because it has a minus term here and a plus term here. Ratio is negative. So if delta t is positive, from 15% to 20% taxes have gone up, delta t is positive, 20% minus 15%, which is 5%, all right, divided by 100, whatever it comes to be, 0.05 probably. And delta y will be a negative term then. Output would fall, income would fall if taxes go up. Why? Because if more taxes go up means this is Keynesian model. If tax rates go up, people spend less. So lesser amount of demand or demand shrinks. So lesser amount of extra output or income that will be produced in the economy. In fact, it can fall. So output would fall. So the whole thing, Keynesian philosophy, is just not the government's role. It essentially depends upon this marginal produce to consume, etc., which people have spent, which wasn't there in the classical model, no consumption function. So one can say the most crucial assumption that Keynes made compared to the classical macroeconomics is the introduction of the consumption function. Because with consumption function, you have marginal produce to consume working, which means there's a multiplier which will work. You saw that delta y over delta g is 1 over 1 minus c, and now today we have 1 over 1 minus c into 1 minus t. If c is not there, there is no multiplier. All right? So it's very critical. So the Keynesian main contribution is the introduction of the consumption function, which creates the multiplier. And now, problem with the multiplier is what you realize, it can have both directional effects. It can have a positive impact and a negative working also. If taxes increase, the multiplier works in the reverse direction, keeps on reducing output for a long time. So the shocks and the aftershocks go on in the economy. Also in the reverse direction, because you have increased taxes, you reduce people's income permanently in some sense, or at least in the short run. And therefore, they will have multiple effects, ripple effects on the economy in reduction of income and output. Similarly, if taxes are cut, it will have multiple effect on the economy in increase income and output. I can go home and tell my wife and kids that, I have no extra income, taxes have gone down, I can spend more, let's go to rave. Then the rave people earn that money, More people work there, that money they spend again. It goes on and on and on. Do you see my point? So I have more or less done, except a little bit I may talk about budget multiplier, etc., balanced budget multiplier, a little bit of Keynesian cross model, but the Keynesian cross model is more or less done today.